Most Barndominium kits are built in one shape. A rectangle. Bolt the steel together for walls, one roof line done. So what happens when you try to build one shaped like the letter Y? 3 wings meeting at a single point, 3 roof lines trying to become one, and a steel frame that was never designed to do what you are about to ask it to do. I built one. Or rather, I spent 4 months figuring out why almost nobody does and what it actually takes to make a Y-shaped Barndo stand up, shed water, and pass inspection. Stick around, because the part where the 3 roof valleys meet in the center is the part that either makes this design brilliant or turns it into a very expensive leak. Before we get into the steel, hit subscribe right now. This channel breaks down the housing designs nobody else will touch. No sponsorships, no affiliate links, just the actual engineering and the actual numbers. If you have ever looked at a floor plan and thought that looks impossible to build, you are exactly who this channel is for. Here is what is coming. I'm going to show you why a Y-shaped footprint is structurally nothing like an L or AT. Why the central hub is the single most expensive square footage in the entire build. And I'm going to give you the real cost per square foot once you add custom engineering on top of a standard metal kit. But the detail that actually matters, the one that determines whether this design works or fails in year 3, is what happens at the valley junction where all 3 roofs collide. I am saving that for the end, because you need to understand the rest of the frame first for it to make sense. Let's start with why anyone would want this shape in the first place. A rectangle is efficient, but it is also a hallway with rooms attached. A Y shape gives you 3 distinct wings radiating from shared core. One wing becomes the primary bedroom suite, tucked away from noise. One wing becomes the living and kitchen space, usually the widest of the 3 to catch the best light. The third wing becomes a garage, workshop, or guest suite. The center, where all 3 meet, becomes your entry, your mechanical room, and often a vaulted great room that borrows height from all 3 roof pitches at once. It is also a shape that solves a real problem on odd-shaped or slope lots. A long rectangle needs a long flat pad. A Y shape can wrap around a hillside, follow a property line, or open 3 separate views in 3 separate directions. I have seen buyers choose this shape specifically because their lot had a creek on one side and a road on another, and a rectangle would have forced them to stare at pavement from every window. But here is the trade-off nobody tells you about up front. Every one of those advantages comes from breaking the one thing that makes metal building kits cheap. Standard shape. A typical pre-engineered metal building kit, the kind you get from most Barndominium suppliers, is designed around a rigid frame system. Steel I-beam columns and rafters bolt together in a repeating pattern down a rectangular footprint. The manufacturer runs one set of structural calculations for that rectangle, stamps it, and ships it. That is why a 40 by 60 kit is affordable. The engineering cost is spread across a shape the factory has built 1,000 times before. The moment you introduce a Y, you're no longer buying a repeating pattern. You're buying 3 separate rigid frame runs that all have to terminate at a shared structural node in the center. That node has to carry the vertical load from 3 different roof systems, resist the lateral thrust from 3 different roof pitches pushing outward at 3 different angles, and do it all without a single continuous ridge beam to tie it together the way a standard gable roof would. Most metal building manufacturers will tell you flatly that this is a custom design. It is not a catalog item. You are paying for original structural calculations, not a modified version of an existing plan. Expect to pay a structural engineer somewhere in the range of $100 to $220 an hour for a design like this. And depending on complexity, a full custom stamp plan for a multi-wing structure like this can run several $1,000s higher than a standard rectangular plan of the same square footage. Let's talk about that center point, because it is doing more structural work than the rest of the building combined. In a standard Barndo, your roof loads travel straight down through rafters into columns into a foundation. Simple, predictable, and the reason clear span steel construction can eliminate interior load-bearing walls in the first place. Column-free interiors are one of the main reasons people choose steel over stick framing for these builds. In a Y-shaped structure, 3 separate roof systems are trying to dump their loads into the same general area. Wind load from the north wing, snow load from the west wing, and the dead weight of the roofing material from the south wing are all converging on a hub that has to be engineered as its own structural zone, essentially a mini building in the middle of your building. This usually means one of two solutions. Either you install a substantial steel column cluster or a built-up structural post at the center that can be visually integrated into the design, often becoming a striking architectural feature in the great room. Or you use a series of transfer beams that redistribute the load out to the perimeter columns of each wing, which requires heavier gauge steel in those specific members and a more sophisticated connection design at every joint. Either way, this is not a place to cut corners or use a generic bolt-up connection kit. The clips, the plate thicknesses, and the bolt patterns at the hub need to be specified for the actual combined load case, not just pulled from a standard catalog detail. Your foundation has to mirror this complexity. A rectangular barndo typically sits on a simple slab or a perimeter footing with a slab floor. A Y-shaped footprint means your foundation plan now has 3 separate wings meeting at a central point, and that center needs reinforced footing size for the concentrated column loads coming down from the hub. Standard slab foundations for Barndominiums run in the range of $6 to $14 per square foot. For a Y-shaped structure, budget for the high end of that range or beyond in the hub zone specifically, because that is where you are pouring thickened footings under the structural columns rather than a uniform slab edge. Frost depth matters here too, and it matters more than usual. If you're building somewhere with real winters, your footings at the hub need to go below the frost line, just like everywhere else. But because the hub is carrying more concentrated load, an engineer may call for a deeper or wider footing specifically at that point, even if the rest of your slab uses a standard perimeter thickening. Now we get into roofing, and this is where a lot of ambitious floor plans quietly fall apart. Every place 2 roof planes meet at an angle, you get a valley. A valley is a channel. Water runs down it, concentrates, and needs somewhere to go. In a standard gable roof, you might have 0 valleys or maybe 2 at a simple dormer. In a Y-shaped roof, you have 3 separate ridge lines converging toward the center, which means you have multiple valleys converging toward the same central point at the same time. This is the single most common failure point on unconventional roof shapes, and it is not really a structural failure. It is a water management failure. If those valleys are not detailed correctly, with proper underlayment, ice and water shield in cold climates, and metal valley flashing size for the actual water volume that point will see during a heavy storm, you get concentrated leaking exactly where 3 roof lines meet, which is usually directly above your great room ceiling. Metal roofing actually helps here more than shingles would, because standing seam and PBR panel systems can be custom fabricated with longer valley runs and fewer seams than composite shingle valleys. But the panel layout still has to be planned around the actual geometry of your Y, and this is not something a standard kit drawing package is going to hand you. Your roofing subcontractor or your kit manufacturer's engineering team needs to walk through the valley intersection points specifically on paper before steel gets ordered. One of the selling points of pre-engineered metal kits is speed. Bolt-together framing, precision-cut components, and assembly that can move faster than stick framing because the steel arrives ready to connect rather than needing to be cut and fitted on site. With a Y shape, that speed advantage shrinks, but it does not disappear. You're still getting factory-cut, factory-drilled steel members. What changes is the sequencing. Instead of raising one continuous frame down a rectangle, your crew is typically raising each wing as its own mini frame, then tying all 3 into the central hub as the final and most critical step. That hub connection is usually where you want your most experienced crew members and, frankly, where you want an engineer or a very qualified foreman on site, not just the assembly manual. Expect this to add real time to your build schedule. Not because the steel itself is harder to lift, but because the tolerances at the hub are tighter, and getting 3 separate wings to align correctly at a shared point takes more careful measurement and more adjustment than bolting a straight run of columns down a rectangle. Let's talk real numbers, because this is where a lot of Y-shaped Barndo dreams either survive or die on the spreadsheet. For a standard rectangular Barndominium kit in 2026, you're generally looking at $20 to $35 per square foot for the kit itself. Materials only before assembly, foundation, or interior finishing. Fully finished and installed, a typical Barndo runs somewhere between $65 and $175 per square foot, depending on region, finish level, and local labor costs. Now take that same square footage and route it through a Y-shaped footprint. You're not just adding a percentage for complexity, you are adding several distinct cost categories that a rectangular kit simply does not have. Custom structural engineering instead of catalog engineering. Reinforced hub framing with heavier gauge steel at the central connection. Custom valley flashing and roofing layout instead of standard panel runs. Reinforced footings at the hub instead of a uniform perimeter slab edge. A realistic planning number is to budget 15 to 30% above a comparable rectangular kit's total installed cost, with the biggest single line item increase coming from structural engineering and the hub framing package specifically. On a modest 2,000 square foot Y-shaped home, that can mean an extra $20,000 to $50,000 over what the same square footage would cost as a straightforward rectangle, depending heavily on your local wind and snow load requirements and how ambitious your central hub design turns out to be. If you're in a high wind or heavy snow zone, push toward the higher end of that range. Load requirements do not just add cost uniformly. They add cost disproportionately at every point where structural members converge, and in a Y shape, that means the hub gets hit the hardest. One more thing worth knowing before you fall in love with a rendering. A Y-shaped footprint is going to draw more scrutiny from your local building department than a standard rectangle, simply because plan reviewers see rectangles constantly and see multi-wing structures rarely. Expect more questions, potentially more review cycles, and make sure whatever engineer stamps your plans is licensed in your specific state and comfortable defending the hub connection design if a reviewer pushes back on it. Get your wind and snow load requirements confirmed for your exact site before you finalize the kit design, not after. Those numbers drive column sizing, footing depth, and connection hardware at every single joint, and changing them after steel has been ordered is a very expensive mistake to make. Alright, here is the piece I told you I was saving for the end, because now you have the full picture to understand why it matters so much. At the exact center of a Y-shaped roof, where all three valleys want to converge into a single point, you cannot just let three roof planes crash into each other and hope the flashing works itself out. This is what separates a Y-shaped Barndo that lasts 30 years from one that develops a mystery leak in year 3 that nobody can find. The solution most experienced designers use is to avoid a true single-point convergence entirely. Instead, they introduce a small flat or low-slope cricket, essentially a tiny diverter roof section, right at the center where the three valleys would otherwise collide. That cricket splits the water flow before it can concentrate into one overwhelmed point. And it also gives you a mechanical break where you can properly layer your underlayment and flashing in a way that is actually inspectable and reparable years down the road. Skip that detail, try to save the money on it, and you have built a home with a bullseye on the one spot where water damage is both most likely and most expensive to fix because it is usually sitting directly above your open concept great room ceiling, the exact space you built this design to show off in the first place. That's the trade-off at the heart of a Y-shaped Barndo. It gives you 3 distinct wings, 3 views, and a striking central space that a rectangle simply cannot offer. But it demands respect at exactly one point, the hub, both structurally and on the roof. Get that point right, and you have a genuinely unique, genuinely functional home. Get it wrong, and you have built yourself a very expensive lesson in roof geometry. If this kind of deep dive into how these homes actually get engineered is useful to you, subscribe, because this is exactly the kind of build I cover here every week. No sponsors, no fluff, just the real numbers and the real trade-offs. Drop a comment if you want me to break down the U-shaped or the H-shaped version of this same problem next, because the hub detail changes completely once you are dealing with 2 intersection points instead of 1. Thanks for watching, and I will see you in the next one.